In this project, we are using two key types of analytics, descriptive and predictive. These two types are essential for helping us understand the current state of the bus system and for forecasting how the introduction of AI-based buses could reduce driver shortages. So why are we focusing on these two? Descriptive analytics gives us a clear picture of what's happening right now in the bus system. It allows us to identify where the shortages are, how many people are using the buses, and the routes that are under strain. This is important because we need to understand the problem before we can solve it. Predictive analytics allows us to look into the future and estimate how AI buses can improve the system. It helps answer questions like, what will happen if we introduce AI buses, and gives us data-driven insights to make decisions based on those forecasts. Together, these two approaches will give us a comprehensive view of the current bus system and how we can improve it by using AI technology. Descriptive analytics. Let's start by talking about descriptive analytics. This is the part of our analysis where we get a clear picture of the current state of the bus system. The goal is to identify trends, such as how often there are bus driver shortages and how many people are using the buses on different routes. Now, when do we actually use descriptive analytics in this project? First, during data collection, once we've gathered the data, like the number of passengers, the unfulfilled driver shifts, and information about elderly passengers, we use descriptive analytics to summarize it all. We ask, what's happening right now? Next, in data visualization, this is where we make things visual and easy to understand. We create charts and graphs to highlight trends. For example, we might use a bar chart to show which routes have the biggest driver shortages. These visual tools make it easier for us to communicate our findings. And finally, in data preparation, before we can do any analysis, we need to clean and organize the data. It has to be accurate and ready for use. This ensures that when we summarize the data, we're working with reliable information. To sum up, descriptive analytics gives us a clear snapshot of what is happening with the current bus system. Predictive analytics. Now, let's move on to predictive analytics. This is where we look to the future. We use historical data to make predictions. Specifically, we want to forecast how the introduction of AI buses could reduce driver shortages. Here's when we apply predictive analytics in our project. First, in the modeling stage, we build what's called a predictive model. Think of it as a tool that uses past data to forecast future outcomes. For example, we use a linear regression model to predict how many driver shifts might be filled if AI buses are deployed. Next, during evaluation, after building the model, we need to test it. We compare its predictions with real-world data to see how accurate it is. The goal is to measure how well the model can predict the future, based on what we already know. Finally, in model deployment, once we're confident that the model works well, we can use it in real life. The predictions from this model can guide the city's decisions on where and how to introduce AI buses to reduce driver shortages. Predictive analytics helps us answer the question, what will happen if we introduce AI buses? It gives us the power to make informed decisions based on data. Why not diagnostic and prescriptive analytics? You might be wondering, why aren't we using diagnostic or prescriptive analytics in this project? Diagnostic analytics helps answer why did it happen by digging into the causes behind certain outcomes. In our case, while diagnostic analytics would be useful to investigate the deeper reasons behind driver shortages, this project focuses more on predicting the impact of AI buses rather than identifying the root causes of shortages. Prescriptive analytics answers what should we do by recommending specific actions. In more complex projects, prescriptive analytics could suggest the exact number of AI buses to deploy and where. However, in this introductory project, we're keeping it simple. We aim to predict potential outcomes first, and based on those predictions, we'll make decisions rather than relying on prescriptive analytics to automatically generate recommendations. Conclusion. In conclusion, we focused on descriptive and predictive analytics in this project because they give us both a clear view of the present and a forecast of the future. Descriptive analytics helps us understand the current state of the bus system, including whether driver shortages are most severe and how the system is operating today. predictive analytics helps us look ahead and estimate how AI buses will improve the system by reducing driver shortages. Together, these two approaches allow us to move from understanding the problem to predicting the solution. By implementing this analysis, we can make informed, data-driven decisions about how AI buses can improve public transportation in the city.